Hi, in this video we'll begin our look at analytical geometry, and we start with the Cartesian coordinate system. So here is a picture of the XY plane that you are probably very used to. Over here we have a picture of a very famous French philosopher by the name of René Descartes. So he lived in the 16th and 17th centuries and died at a fairly early age of 53. So he is considered the father of analytical geometry. So he was one of the first, or probably the first, to combine algebra and geometry. So analytical geometry is essentially the combining of these two disciplines, algebra and geometry. He is also famous for this quote, I think, therefore I am. There is also this quote, which is less famous, but I think very important. So he said, you just keep pushing, you just keep pushing. I made every mistake that could be made, but I just kept pushing. So let's look at the Cartesian coordinate system. As you may have suspected, the Cartesian coordinate system is so named in honor of Descartes. So in this XY plane, this Cartesian coordinate system, points are defined by pairs of values called x and y coordinates. And any point can be in one of four quadrants. So these areas are referred to as quadrants. This being the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. A point in this quadrant will have both of its coordinates positive. So a point placed right here would have the coordinate positive 4, positive 3. A point in the second quadrant would have the x coordinate negative and the y coordinate positive. So a point here, for example, would be the point minus 5, 2. A point placed in this quadrant would have both coordinates negative. So a point placed right here would have the coordinates minus 2, minus 3. And a point placed in this quadrant would have the x coordinate positive and the y coordinate negative. So a point placed right here would have the coordinates plus x and minus 2. So the sign of the coordinates depends on which quadrant the point is in. So what is the required skill set here? If I give you a point, you should be able to state the coordinates. So if I place a point right here, for example, so let's suppose I place a point right here. So that point, if I give you this point on a diagram, you should be able to say, oh, that is the point minus 2, minus 4. If I place a point here, you should be able to say that that's a point minus 4, 4. If I place a point here, you should be able to say that that is a point 5, minus 2. Likewise, if I give you a point, you should be able to draw it. So for example, if I give you the point written out, let's say I give you the point minus 6, 1, then you should know that that's coming over here, minus 6 and then up 1. If I give you the point, let's say 5 minus 4, you should be able to say, oh, that's this point here. And of course, if I give you a point written out like this or drawn on the diagram, you should be able to see in what quadrant it is. If I drew a point right here, you should be able to say, oh, that's in the fourth quadrant. If I gave you a point here, you should be able to say that is in the second quadrant. Likewise, if I wrote it out this way and I said minus 5 minus 6, you should know that this is in the third quadrant. Of course, the value of the Cartesian coordinate system is not just that we can draw points, but rather that we can visualize the relationship between sets of values. So here is one such relationship, y equal to 2x plus 1. We can visualize this relationship by placing values for x. So let's try some integers here. When x is minus 3, we get minus 5 for y. When x is minus 2, we get minus 3, and so on. We can plot these points, minus 3, 5, minus 2, minus 3, and this is what we get. As you can see, these are beginning to look like a line. In fact, if we could plot all the points between 3 and minus 2. Well, if we plotted all those points, we'd get a continuous series of points with no gaps, which of course then would be a line. So this line represents a unique relationship between x values and y values. This is a linear equation because its visualization gives us a straight line. We can look at another relationship. Here we have one that is quadratic. Again, we can place values for x and get the corresponding values of y. So test these to make sure that they're correct. And then we can plot these pairs of values. Minus 4, 6, minus 3, 0, and so on. So this is minus 4, 6, minus 3, 0, minus 2, minus 4, and so on. And you can begin to see the outline of a parabola here. If we plotted the infinite points between these values, we would get a smooth curve. So here we have the visualization of this relationship between sets of values, that is between x values and y values. So Cartesian coordinate system allows us then to visualize the relationship between sets of values. So that's it for this video. Make sure you can plot points and that you can plot equations on the Cartesian plane. Okay, bye for now.